had done in the last class, correct? Yes or no? Yes or no? Good. Yeah. Can you hear me? Yes. Okay. So some of the questions on this chapter we had done in the last class. You remember or not? Remember? Huh. Okay. So today what we are going to do is nothing but we are doing the extension of this. I mean to say we are going to do some questions beyond what we had done in the last class. Okay? Yes. Okay. I hope everybody is ready with that. So we'll start. Let's say from which question had we stopped in the last class was this particular question where I said that KCET questions here there is a certain mistakes which has been occurred, and because of which this particular question was given as a grace mark. Do you remember that? You remember this? Or you were sleeping in the last class? Yes? Students, is the mic there with you or not? The first thing is that. Yes? So last class we did with one numerical where I said that in KCET, bubbling of all the questions is very important. The reason is nothing but some of the questions will come as faulty, due to which grace marks will be awarded. If you don't know, 2023 paper, I hope if I'm not wrong, 52 questions were wrong. If I consider physics, chemistry, maths and biology all together, 52 questions were wrong. 52 questions were given as grace marks. Can you understand that? Last class even I told you that if there is a 1 mark difference in KCET, your rankings will go up by 1000 numbers. So 52 questions wrong, it means that everyone went with an increase of 52,000 ranks. I hope you are understanding this. Yes, so it is very important to understand, okay? So whenever we say, we are not mad here, whenever we say that you have to click on all the questions, all the bubbling is required, the reason is nothing but faulty questions, you will get the grace marks. I hope it is clear. Yes, okay, good, fine. So do you remember at least now that last class I told you that this is an faulty question due to which grace marks will be given. Do you remember that? Yes, okay, fine. So for today what we are going to do is nothing but we are trying to do with numericals which is based on this particular thing. Okay, that is nothing but Biot-Savart's law. Clear? Yes? Just a minute. Okay, so we are going to do it on Biot-Savart's law. So what is Biot-Savart's law? Anybody can tell me? What is Biot-Savart's law? Anybody can tell me? Yes? Yes? Can anybody tell me what is Biot-Savart's law? Or you remember, or in PUC second year, have you seen that this particular chapter was done? Yes or no? So any current carrying conductor, if say for example it generates a magnetic field, then that magnetic field can be given by a formula called as mu naught by 4 pi ideal sine theta by r square, correct? Yes or no? The same thing if I want to write it down in vector form, then it will be mu naught by 4 pi I into r cross dl divided by r cube. Did you understand? Not dl cross r cross dl divided by r cube. Is it clear? Yes, okay. Now, when this particular formulation was done, now the different thing which came into picture is nothing but what will happen if the wire is not in this particular position, if it is a straight wire, exactly straight wire, then what will happen? If say for example it is in the form of a circle, then what will happen? Did you understand with this? If at all it is a straight wire, then we have a formula called as mu naught I divided by 4 pi d sine of theta 2 plus sine of theta 1. Did you understand with this? Is it clear? Now again when it has been found out, there are 3 more points here. One is nothing but what if this point is over here, or what if the point is over here? So over here in the sense the point is like this. Did you understand? Is it clear? if at all the point is here, then we call it as a semi-infinite wire. Semi-infinite wire. We call it as a semi-infinite wire. Did you understand? Is it clear? Huh. When it is a semi-infinite wire, I have done a small mistake here. It shouldn't be 2, it should be 4. Okay. When it's a semi-infinite wire, what will happen is, okay, one angle will become as 0, other angle will become as 90. Other angle will become as 90. Did you understand? So what will happen when one angle is 0 and other angle is 90? So 0 will become as sine 0 is 0, sine 90 is nothing but 1. 1 multiplied by mu naught I, so you will get it as mu naught I divided by 4 pi d. Did you understand with this? Huh. If say for example this same point P is here, if say for example the same point P is here, that is nothing but not here, here, okay, or say for example if it is here, then this is called as an axis of the wire. So on axis of the wire, magnetic field will be equal to, it is always 0. Did you understand this? Is it clear? Any doubt? Perfect. Okay. Now say for example this particular wire is made in the form of a circle, and if I am trying to find out it on a point called as P over here, okay, on the axis, because this particular thing was there in for you for 5-mark derivation, am I right? A magnetic field at a point on the axis, circular coil carrying current, am I right? This is a 5-mark derivation, correct? Huh. When you do that derivation, do you get this formula? Mu naught I r square divided by 2 times of r square plus x square raised to 3 by 2. Huh. Perfect. Okay. Now one more thing is nothing but what will happen if this point P shifted from here and it is brought at the center. When it is brought at the center, x value will become a 0, correct? Yes or no? So if x value is 0, then what will happen? B will be equal to mu naught times of I divided by 2r. Did you understand? Okay. So one more thing what we have to add up here, is nothing but okay. So if say for example there is a circular coil carrying current, if at all there is a circular coil carrying current, okay, then magnetic field at the center will be equal to, magnetic field at the center, I might consider it as B naught, okay, magnetic field at the center will be equal to mu naught times of I divided by 2 times of R, where R stands for radius and I stands for current, correct? Yes or no? But questions appear like this. That is nothing but what is the magnetic field produced by a wire like this? Or what is the magnetic field produced by, let's say, like this? Semicircle. Did you understand? Yes? Is it clear? Now in this case, how do you find out? Let's say for example, to complete a complete circle, the total amount of angle covered is nothing but it is 2 pi radians. Am I right? Yes or no? For 2 pi radians, the value is nothing but how much? Mu naught times of I divided by 2r. For any other angle, say for example theta radians, what will be the value of magnetic field? So magnetic field value will be equal to, it is nothing but mu naught I divided by 2 times of r into theta divided by 2 pi. This is the formula. This formula you should remember. Okay, or otherwise B dash is equal to mu naught I divided by 2 pi r is nothing but B naught. So B naught into theta divided by 2 pi. This formula is also okay. Whichever you feel that it's a shortcut formula, you can just note down. Clear? Got it? Perfect. Okay. So shall we solve with the problems? Okay. Okay, see here. A magnetic induction at the center O in the figure is given by. So can you see this figure? Okay, based on this, can I say that the total magnetic field generated at the center, let's consider this as O. Okay, let's consider this as O. The total magnetic field generated at center O is because of this arc, this straight line, this arc, and this straight line. Is it yes? Students, is, sorry? Ha. The total magnetic field generated at point O is because of this arc, one magnetic field. This is one straight line, another magnetic field. This is another arc, one more magnetic field. This is another straight line, another magnetic field. Correct? Huh. So can I say total magnetic field B naught is equal to, it is nothing but B because of BC plus B because of CD plus B because of DA plus B because of what it is, AB. Am I right? Correct? Huh. Now, see here for this one, AB and CD, can I apply this formula? Can I apply this formula? On the line, if the point is on the axis, the magnetic field is equal to 0. Correct? So can I apply the same formula here? On the line, if the point is on the axis, then it is equal to 0. Correct? Huh. So what will happen? AB and CD is gone. So AB value is becoming as 0 and CD, right? CD value is also becoming as 0. Correct? Yes or no? Huh. Now, how much is the angle covered here? If it is a complete circle, it is 2 pi. How much is the angle covered here? Huh? Pi value. So how did I tell that is nothing but we have found out B naught is equal, sorry. In the last synopsis, B dash is equal to mu naught into I divided by 2 times of R into theta divided by 2 pi. Correct? Huh. So theta is equal to how much here? Pi value. Theta is pi. Students, are you understanding or not? Theta is pi. So pi and pi value got cancelled. So how much is the value now? Mu naught times of I divided by? Correct. Okay. Now tell me how much will be the value of AD? BAD will be equal to, it is mu naught times of BAD, right? Okay. Mu naught times of I divided by 4 times of R2. Correct? And B of what? BC will be equal to what? Mu naught times of I divided by 4R1. Correct? Now magnetic field, you can see that they are inversely proportional to R. Inversely proportional to R. It means that if R increases, magnetic field will decrease. Perfect. So which magnetic field is more? Is BC more or is AD more? AD magnetic field is more. AD magnetic field is less. BC magnetic field is more. Okay. Check with right hand thumb rule. Direction of the current is like this, so magnetic field is outside. Direction of the current is like this, so the magnetic field is inside. So the net magnetic field B will be equal to, which is more? BC is more. B of BC minus B of AD. Correct? Put these values and tell me which is the right answer among the 4. Option A is correct answer. Sure? Okay, let's see. Yes, option A is the correct answer. Did you understand now? Is it clear? Perfect. Okay, shall we go with the next one? Okay. Try with this. Try with this. A battery is connected in a between of 2 points A and B on the circumference of the uniform conducting ring of radius r and resistance r. One of the arcs AB of the ring subtends an angle theta at the center. The value of the induction at the center due to the current of the ring is. Okay, what does he wants to say? It means that there is a circular ring. There is a circular ring. Let's say, for example, this is the circular ring. Let's say, for example, this is the circular ring. Okay, there are 2 points on the circular ring. So let's consider there are 2 points on the circular ring. One point, let us consider it as this point A. One point, let us consider that, I'm so sorry, that is this point, that is B. Okay, let's say this is the radius. This angle is nothing but theta. Okay, now this A and B is connected to one battery. A and B is connected to one battery. Am I right? Till here it is correct? Okay. Now, this is theta. The rest of the angle is how much? 2 pi minus theta. Correct? Yes or no? Yes. Now, let's say, for example, if this battery is there, the current is going I like this, then the current is going I like this, then the current gets divided into 2 parts by Kirchhoff's law. One will go like this, one will come like this. Correct? Perfect. So it means that net magnetic field at the center, net magnetic field at the, sorry, I'll use some different color. Okay. Net magnetic field at the center is equal to magnetic field produced by bigger arc, that is large arc, minus magnetic field produced by the smaller arc. I'll write down like this. Why have I written larger arc minus smaller arc? In the problem previous, the distance was different. But here the distance is same, correct? R value is same in both cases. Which means that bigger the wire, bigger magnetic field, smaller the wire, smaller magnetic field, because the distance are same, correct? So bigger the wire, I have put it as bigger large, smaller the wire, I have put it as small. So large minus small. Did you understand with this? Now see what will happen. Here it is mu naught times of I divided by, it is 2 times of R. Angle covered is 2 pi minus theta whole divided by 2 pi. Correct? Here it is what? It is mu naught times of I. Angle covered is theta divided by, you have 2 times of R and angle is 2 pi. Correct? So in both the cases, mu naught I 2R into 2 pi is nothing but 4 pi R. Is it common? So what will happen if I put this? What will happen? So that is nothing but mu naught times of I divided by 4 pi R. If it is common, in a bracket it is left out by 2 pi minus theta. Correct? So 2 pi minus theta is nothing but 2 theta. So here 2 and 2 is common. So I can write down this as mu naught times of I divided by 4 pi R 2 times of pi minus theta. Correct? So 2 and 2 here gone. So therefore net magnetic field B will be equal to mu naught times of I pi minus theta divided by 2. Correct? Perfect. Now see. First option what they have given, proportional to 2 times of 180 minus theta. Is it proportional to 2 times of 180 minus theta, or is it proportional to only 180 minus theta? Just 180 minus theta. So this option is wrong. Okay. Inversely proportional to R. Is it inversely proportional to R? Yes. So this is correct. Okay. It will be 0 only if theta is 180. So say for example this theta is 180, 180 means pi minus pi is 0, so B will be equal to 0. So this is also correct. Am I right? Yes. Okay, theta for, 0 for all values of theta. So it means that you put any value of theta, B will be equal to 0, he is saying. Is it correct? No. Theta, if you put pi by 4, will you get B is equal to 0? No. Am I right? So it means that this value is also wrong. So how many answers did you get correct? B and C. But KCET, does it offer two answers correct? No, KCET only offers one right question, correct? One right answer. Am I right? Huh. But what does KCET have? KCET has a freedom of pushing the questions or pulling the questions from any other competitive patterns also. If you see JEE earlier papers, there would be questions which would have answers more than one right. They would tell, saying that there are certain questions which has more than one right answers, so you can correct both the things. Okay, might be, I don't know, might be these people have pulled the question from JEE paper and they have put it over here where it shows that B and C both are the right answers. Is it right? Such kind of times what happens is nothing but, even if the student has given B as 1 point as the correct ones, or if you have given C as 1 point as the correct ones, what will happen is nothing but you will get awarded with marks. I hope it is understood. Is it clear? Depends how they give. But what happens is nothing but you might get the things. That is the reason why whenever you come across with such kind of questions and when you feel that both of them are right or any one of them are right, please bubble it, don't leave it. Did you understand? Is it clear? Okay, so let's see if the solutions B and C are right or not. See, both B and C are right. Correct? Did you understand now? Any doubt here? No. Okay, fine. Now for this question, please use the cue card and let me know. This is a very easy question. There is an arc given. In that arc, this much part has been thrown out. Rest of the things what you need to do is nothing but you need to find out the magnetic field using which formula. This is the formula, or simple formula is nothing but B dash is equal to, it is it is mu naught times of I divided by 2R into theta divided by 2 pi. Calculate and let me know. Tell me. How much is this angle? First tell me this. How much is this angle? Hey, this angle we need to find out, not 60. This is 180. In your town, this is 180. 300. How will you write on 380? It is nothing but 360 minus 60. Am I right? Yes or no? Huh. This will give us how much? 5 pi by 3. Correct? Yes or no? Then put that value and tell me how much you are going to get. Fast, fast, everybody should answer. Good. Most of them are answered D as the answer. Is that the right one? Yes? So if I put 5 pi by 3, then what will I get? 5 pi by 3, if I put it over here, 5 pi by 3 is nothing but 3 2s are. Where did we go wrong? Mu naught I divided by 2R into theta. Theta is not 5 pi by 3. Okay, so 5 pi by 3 divided by 2 pi. So it means that it will give you as 5 by 6. 5 by 6 if I multiply with mu naught I by 2R, 6 2s are 12. Correct. So option D is right answer. So let me see if option D is right. Correct. Very good. Very good. Okay. So can we go with the next one? Can we go with the next one? Yes? Okay, okay, fine. So if I go with the next, okay. Now what is given? The magnetic field at the origin due to the current element dl. This is direct question. What should be the answer for this? This was there in the synopsis. This was there in the synopsis. Option? So why is it not option C? Why is it not option C? Why is it not option C? So A cross B is never equal to B cross A. Correct? Yes or no? So dl cross R is not equal to R cross dl, which means that which do we want? We want this one. We want this one. So it means that the correct answer will be this one. Right? Yes or no? So let's see whether the answer is correct. Yes, the answer is right. Understood? Okay, fine. We'll go to the next one. Okay. Now can you do this? This is the same type. This is the same type. Here what we have to do? Here what we have to do? Net magnetic field on O is equal to magnetic field generated by AC plus magnetic field generated by arc CD plus magnetic field generated by DE. Am I right? Net magnetic field generated by AC will become as 0. Correct? So left out is nothing but B naught is equal to B of CD plus B of DE. Correct? Is D 0? Is D 0? How will you find out magnetic field for DE? Magnetic field for DE will be equal to mu naught I divided by 4 pi D value. D value is how much? That is R value into sine of theta 1, that is nothing but 90, plus sine of theta 2, that is nothing but 0. I told you whenever it is a semi-infinite circle, one angle will become 0, one angle will become 90, correct? So what will happen? This answer will be BDE is equal to, it is nothing but mu naught I divided by 4 pi R. Okay. What about this one? BCD. BCD will be equal to mu naught times of I divided by 2 times of R into how much is the angle? How much is the angle? It is 3 pi by 2, 1 pi by 2, 2 pi by 2 and 3 pi by 2, correct? Yes or no? Theta divided by 2 pi is the value what we need to find out. Theta is nothing but 3 pi by 2. 3 pi by 2 by this 2 pi, if you do, what will happen? 3 will be on the top, 2 will come on the bottom, 2 to the 4, 4 to the 8. So this will become 3 times of mu naught times of I divided by, it will become as 8 pi D, correct? 8 pi, not D, R, correct? Yes or no? Understood? Okay. Now see, direction of CD, direction of ED, this is in this direction, so the magnetic current is, so magnetic field is inside. This is like this, so the magnetic field is outside. Both of the magnetic fields are opposite. Hence, the net magnetic field B naught will be equal to, it is a difference between magnetic field of CD with that of what? It is DE. Correct? Yes or no? By seeing this only, what we can do, we can neglect option number A and option number C. The reason is nothing but there is plus sign here, there is plus sign here. Only thing is what? Whichever is the minus sign, either this might be correct or either this might be correct. Yes? Which one is correct now? We have found out 3 by 8 mu naught times of I here, and we have found out mu naught I divided by 4 pi R here. So it means that these two values are correct. This is the right answer. This is the wrong answer. Did you understand now? Is it clear? Okay, let's see whether if it is correct or not. Yes, B is the correct answer. Did you understand now? Is it clear? Any doubt? Any doubt? Okay, some boy was saying something. Some boy was saying something, some doubt. Tell me. What if the wire was not semi-infinite and it was infinite? Yeah? The boy who has questioned, is it correct? That is what is your doubt? So now, see, if the wire is like this, if the wire is like this, if the wire is like this, okay, let's say for example this is also extending in this direction. Let's say for example this is also extending in this direction, okay, and it is going till infinity. It is going till infinity. There is no end. It is keep on going till infinity. But you are calculating the magnetic field at a point which is at this particular point, at one end. Here. This point. Then you call this structure itself as a semi-infinite. Did you understand? Is it understood now? What do you mean by semi-infinite? So here also what is happening is nothing but it is an infinite wire only, but the point what I am calculating is nothing but is at one particular point. Did you understand? Say for example, as per your question, what happens if this also extends to infinity, then what will happen? Tell me. Theta 1 will also become as 90 degree, theta 2 also will become as 90 degree. So you have a formula called as what? Mu naught times of I divided by 4 pi d. Then sine of theta 1 is 90, sine of theta 2 is 90, so it will become as 2. So 2 ones are 2 twos are, hence your answer will become as B is equal to mu naught times of I divided by 2 pi d. Did you understand this? Clear? Okay. Shall we move with the next question? Okay. Okay. Now, a circular coil of wire of radius r has n turns and carries a current I. The magnetic induction B at a point on the axis of the coil at a distance root 3r from the center is simple. So what they have given is nothing but we have this formula with us. We have this formula with us. He is just saying that in place of x you take it as root 3r. Put root 3r in place of x and tell me what is the value of B. How much should be the value of B? Yeah, what will be the value? What will be the value? What will be the value of B? B is equal to mu naught times of Ni r square divided by 2 times of r square plus x square raised to 3 by 2. What will be the value? Option B. D 8r. Okay, so let's see some mistakes. I think so some mistake has been done. Let's see. I think so the mistake is here only. So let's take it as r square plus x square raised to 3 divided by 2. Okay, so here it is r square plus x is nothing but root 3 times of r, the whole square. Again that whole thing is been raised to 3 divided by 2. So this will become as r square plus 3 root 3r the whole square will give you as 3r square whole raised to 3 divided by 2. So hence what will happen is nothing but 3r square plus r square will give you as 4r square raised to 3 by 2. Now split this into two parts. That is nothing but 4r square. You take it as half first, then multiply it with 3. So half in the sense root of this will give you as 2 times of r, then multiply with 3 is nothing but 3. So you are going to get this as 8r cube. So the answer of r square plus x square raised to 3 by 2 when x is taken as root 3r is answer is nothing but 8r cube. I hope it is understood. Is it clear? So in place of this you have to put 8r cube. If you put 8r cube, how much is the answer you are going to get? So it means that you have calculated 8r cube, r square and cube also you cancelled, but you forgot to multiply 8 with 2 here. Yes? Yes or no? Correct? Am I right? So the answer will be B is equal to mu naught times of NIR square divided by 2 into 8r cube. Hence r square and 2 times of r gets cancelled. 8 and 2 becomes 16. So your answer is mu naught times of NI divided by, it is 16 times of r. Correct? Yes? So let's see whether the answer is right or not. Okay, sorry, not here. Yes, mu naught times of Ni divided by 16r, correct? Okay. So shall we go with the next question? Okay. Try with this. What is given? A proton and an alpha particle moving with the same velocity enters into a uniform magnetic field with their velocities perpendicular to that of the magnetic field. The ratio of the radii of the circular path is, okay. What is alpha particle? Proton is, let us consider this as proton. Proton is proton only, can't change. Okay, we'll talk about alpha particle. What is alpha particle? What is alpha particle? Alpha particle is nothing but it is an helium atom, correct? Yes or no? What is helium? Helium is nothing but it is a particle which has 2 protons and 2 neutrons, correct? Yes or no? So mass of an alpha particle will be equal to that of 4 times of mass of a proton, but charge of an alpha particle will be equal to just 2 times of charge of the proton. So if I consider here mass of the proton is nothing but m of p and charge of the proton to be as q of p, then I can relate this both by this particular relation, correct? Yes? So I have put these values. What you need to do is nothing but you have to put it into this. So r of proton, if I want to calculate, it will be mass of proton, velocity divided by charge of proton into b. In the next case, alpha particle, it will be nothing but mass of alpha particle, that is 4 times of mass of proton into v divided by, it is nothing but 2 times of charge of proton into b. So then what will you get? R of proton divided by R of alpha. How much will you get? 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 Option D. 1:2. Okay, so answer is, if I take this is 2 ones, this is nothing but 2 twos. So if I multiply RB by alpha is nothing but 1 divided by 2. Correct. Yes, 1 divided by 2 is the answer. So your answer should be option D, that is 1:2. Let's see if the answer is correct or not. Yeah? Okay. So answer is 1:2. Correct. Did you understand now how to do? Yes? Perfect. Good. Okay. Let's try with something else. Okay, this is next set. This is next set. okay, of synopsis. Okay, so here what we are trying to understand is, one is Ampere's circuital law. Ampere's circuital law, how it can be given, that is nothing but B dot dl is equal to mu naught times of I. This is there in your textbook. Okay, magnetic field of a solenoid, that is nothing but mu naught times of Ni. That is the formula. But the thing is nothing but, if say, sorry, not solenoid, this is for long solid cylindrical conductor. I'm so sorry. If say for example the cylinder is solid, then this all things is not required. This is not asked in KCET. You just need to see about the graph. The graph for a solid cylinder will be inclined, then you have a steep. But if at all it is a hollow cylinder, it will be directly a steep. Did you understand with this? Is it clear? Yes. Okay, good, fine. Now when it comes to solenoid you have two things. One is nothing but, say for example, this is the solenoid in the form of rings. If at all, if it is in the form of rings like this, then you have three areas where you need to calculate the magnetic field. One is at the center, one is at the edge, and one is outside. Sorry, one is outside. At the center it will be equal to mu naught times of Ni. At the edge it will be equal to mu naught times of Ni by 2, and outside it will be equal to 0. Did you understand? Is it clear? Okay, fine. Now based on this, there is a last section also, that is nothing but conversion of galvanometer into voltmeter. This particular thing is a 5-mark derivation for you. Do you remember this? Force between two parallel conductors, if they are moving in the same direction, it is an attractive force, which can be given by mu naught times of I1 I2 dl divided by 2 pi d. Am I right? Yes. Okay, if it is moving in the opposite direction, then the force is repulsive, correct? Now current sensitivity can be given by, or sorry, shunt resistance can be, what is shunt resistance? What is shunt resistance? How do you convert galvanometer into ammeter? If at all you take a very small negligible form of resistance and connect it parallel to that of the voltmeter, sorry, parallel to that of the galvanometer, then that setup will act as an ammeter, correct? That resistance is called as shunt resistance. That is nothing but, yes, correct. One question usually appears saying that, what is the value, what is the value of shunt for ideal ammeter? If they ask you this, the value of yes should be equal to
0.
perfect. Okay, or what is an ideal ammeter? Ideal ammeter is that ammeter in which the value of the shunt resistance applied is equal to 0. Similarly, if say for example it is an ideal voltmeter,
Infinite.
very good, because this is one of the Viva questions. Ideal voltmeter, the value of the resistance will be equal to, it is infinity. Infinity. Okay, now one thing you understand, how do you call this one as shunt resistance? There is a name given to it, right? It is called as a shunt resistance. What is this name given for R here? Anybody knows? Anybody knows? If you don't know, it is called as ballast resistance. BALLAST, ballast resistance. Okay, because this is not there in your NCERT or neither in any of the books. If say for example they give you in the KCET questions saying that there is some ballast resistance being connected, then you should be able to remember that this is what it is. Okay? Yes? Okay, fine. Can we go with the next? Now tell me, what is the value of shunt resistance required to convert galvanometer to resistance 100 ohms into an ammeter of range 1 amp? So what is given? Shunt resistance value required for the galvanometer is to be calculated. No, shunt resistance value is given. No, shunt resistance value is to be calculated. For galvanometer resistance is equal to 100 ohms. So it means that they have given you this value, which is equal to 100 ohms. Then again what they have given? Ammeter range is 1 amp. So this is nothing but 1 amp. And galvanometer current they have given us how much? Full scale deflection, it is 5 milliamp. 5 milliamp is nothing but it is equal to 0.005 amp, correct? Yes or no? Now put the value, tell me how much is the value here. So this is nothing but 0.005 whole divided by your I is equal to 1 minus this is 0.005 and multiplied with the value is nothing but 100. So when I multiply 100 with 0.005, it gives you as 0.5 and divided by here 1 minus 0.005 will give you as 0.995. So do you have this answer? Okay, they have shifted the points. So this is nothing but 5 divided by 9.95. Do you have an option like this? Option B. Understood now? Yes, perfect. Okay, let's see if the answer is correct or not. Yes, 5 divided by 9.95 is the correct answer. Did you understand now? Yeah? Huh. Okay. So this usually completes the whole of the chapter of moving charges and magnetism. There is nothing left out in this chapter. Everything is over here itself. So what I have done is nothing but I have added some assignment questions to you. I have added some assignment questions to you. These assignment questions are between 2014 to 2019. Why I have taken only questions from 2014 to 2019 is nothing but one, you get an exposure with KCET questions. Second is nothing but in between 2014 and 2019, the syllabus was not rationalized. Post 2019, the syllabus got crunched and rationalization took place. Did you understand? For that reason, there might be some questions which might be out of syllabus, but before this, whatever we did, they were all within the syllabus only. Is it understood? Is it clear? Okay, so please follow with this. This assignment and the PDF will be sent to you. Please follow with this and make sure that you are studying according to it. Is it clear? Okay, so please give the feedbacks. Please give the feedbacks also. Yeah? Sorry? Second year PUC has classes. Second year PUC have classes tomorrow. Okay? You have physics class. Yeah? Only physics class. Okay? Yeah, yeah. Yeah. Yeah, tell me.